Hello everybody, this is Mr. Regner and this is our Chapter 8 practice test. You'll find this practice test on page 406 inside your Big Ideas textbook. So without further ado, let's go ahead and take a look at it. Now I've got my webcam here, and so some of these problems I will work out for you, and some of them I may kind of skip over because maybe we can just look at one example versus all of them. If you have specific questions, always feel free to reach out to me through email at adam.regner@perrylocal.org. Let's begin by taking a look at 1, 2, and 3 together. Now these say order the values from least to greatest. And the only tricky part here is maybe that we have these negative numbers. So you might remember making a number line like this in class. We've got our numbers that go up as we go to the right. And that number here, 0, is our smallest number according to this number line. But remember, whoa, we also have those negative numbers. And when you think about our numbers over here, this all makes sense. Opposite land, things are kind of backwards. As we get smaller, it appears that our numbers are getting bigger, but they're not really because they're negative numbers. So -6 is smaller than -5. So a question like number 1, these are whole numbers. We can probably order those by thinking about our number line. I'm not going to draw number 1 out for you. For number 2, I do want to look at this one a little bit closer. So let me go ahead and draw this out here. We've got -8. We have the absolute value of -3. Notice those absolute value bars there. Tell us that's absolute value. The absolute value of 5, we have 4, and we have -5. Now just to kind of help you out a little bit on this one, I'm going to go ahead and take those absolute value bars away and sort of solve those problems. So I'm going to keep -8. The absolute value of -3 is going to be 3. The absolute value of +5 is 5. And then 4 and -5. Now that alone I think is going to help set you on the right track here. If we're going to order these from least to greatest, I'm going to have -8 first, then -5, then 3, 4, 5. I'll kind of write that out here. So -8, -5, 3, 4, 5. If you look at that, -8 is definitely the smallest number. -5, the next smallest. Then +3, 4, and 5. The trick there is we've got to understand our absolute values. Now if you look at number 3 on this problem, or on this page I should say, number 3 involves negative numbers all across the board. They're all negatives, right? But there's a little bit more of a trick to these. No absolute values to worry about, so we're in good shape there. But instead we're looking at decimals. Don't let the decimals scare you. Oops, I think I said they're all negative, but I just noticed there's a +1 there. It snuck in there. So +1, obviously that's going to be my biggest number. I'm going to put that all the way over here for sure right now. If I look at this, -2 is going to be, in the negatives. But -2.293, -2 and 5/10, -2 and 46/100. These are all going to be smaller than -2, even though it looks like they're bigger, right? Because we're in negative land. So -2 is my next smallest. It's almost like I'm going from biggest to smallest here, just because that's maybe the way my mind is working right now. So now I have to look at this and look at the tens place. I have a 4, I have a 5, I have a 2. Well, the tens place is going to be our next value, right? So we think about what's going to be next. It's going to be the 2 in the tens place. This -2 and 293 thousandths, right? And then tens place, I have a 4 here and a 5 here. 5's bigger than 4. So we know that the next one is 2 and 46/100ths. And then 2 and 5/10ths is going to be the smallest number. I almost said biggest there, but that's not what I meant. So that is our order from smallest to largest. Always be paying attention to those place values. Hey, let's move on and let's take a look at numbers 4 and 5. Numbers 4 and 5 say graph the number and its opposite. Well, guys, one thing to know about opposites is that we're just taking the negative and making it positive. We're taking the positive and making it negative. For a number like 4, we have 23. We can graph that, and then the opposite of 23 is -23. I want to look at number 5, though. just to do one of those examples. And on my graph, I'm going to put 0 in the middle. I'm going to put negative 1 1/3 over here. So my opposite, if I'm graphing these, is going to be over here. That's going to be positive 1 1/3. So I'm literally just graphing those numbers, plotting those points. That's numbers 4 and 5. For numbers 6 and 7, it says find the absolute value. Well, guys, again, the absolute value, we're just taking away the negative and making it positive, or making it positive. Absolute value is the distance from that number to 0. The absolute value of 7 equals 7. It's 7 spaces away from 0. For number 7, the absolute value of negative 11 is 11. Absolute value can be one of the easiest things that we're going to be doing in this chapter, unless you forget all about it, in which case it could be very tricky. That's absolute value. Let's move on. Let's take a look at number 8. It says copy and complete the statement using less than, greater than, or equal to. Let's do it. So I'm going to look at just number 8, I think. Because I think number 8 could be a little bit more challenging. It's a fraction. So I have negative 2/3. Got my box here in the middle, and negative 3/5. Now, whenever I'm looking at fractions, it makes sense, probably, to everybody that we should probably try to get common denominators so we can compare them on a level playing field. So I look at 3 and 5, and I want to think of the least common multiple, or LCM. Right? If I make multiples of 3 and multiples of 5, the least common multiple I'm going to come up with is 15. Right? So think about what I did. 5 times 3 is 15, so 3 times 3 is 9. That makes this negative 9/15. Over here, 3 times 5 is 15, so 2 times 5 is 10. That makes this negative 10/15. Now, guys, I know what you're thinking. It looks like 10's the bigger number, but remember, these are negative numbers. In this situation, negatives, it's like opposite land. The bigger number is actually going to be 9/15, because that would be on the right of the number line. So I'm going to put my less than sign there, saying that negative 10/15 is less than negative 9/15. We would do the same thing for number 9. Keep in mind on number 9, you've got absolute value bars, and so that means those two are going to be equal. For numbers really 10, 11, and 12, we want to use a coordinate plane. And so on our test for this, we're actually going to be given a coordinate plane. It's going to be beautiful. It's going to be easy to use. Oops, look what I did. I just messed that up. I made a coordinate plane only using quadrant 1. I should have included all the quadrants. Let me start that again. I got so excited there. I just started drawing it out. Here's my coordinate plane. I've got my y-axis, my x-axis. There we go. All right, so it's giving me numbers like 4, 0, 1.5, negative 3.5, negative 2, negative 3. So I don't need to take these out too far. I'm just going to go 4 on each side. Oh, there's 4. And again, when you're given the grid, it's going to be a little bit easier than drawing it yourself. But for number 10, point J is located at 4, 0. I always start at the origin, go over first, 1, 2, 3, 4, and up 0. Bloop, right here, this is point 4, 0, or point J. Point L, number 11, it says 1 5/10 and negative 3 5/10. So I'm going to go over 1 5/10, that's right about here, and then down, because it's negative, 3.5. That's 1, 2, 3, and then 3.5 would be like right about here. That's 1 5/10 and negative 3 5/10. And we'll call that point L. There you go. And then number 12, point M, it says negative 2, negative 3. So I'm going to go over 2 and down 3. Boop. There's negative 2, negative 3, which we call point M. There it is. So that's how we would graph those points. Number 13 says to reflect negative 5, 1 in A, the x-axis, and B, the y-axis, and C, the x-axis, followed by the y-axis. What? So remember, for this one, we want to use our points, and we're going to reflect those points. So first, I'm going to write down what negative 5, 1 would be. So here's my origin. I'm going to go over 5, which I guess I need to add on that one. negative 5, 1. That's going to be right here. Negative 5, 1. This is my first point. For letter A, it says reflect that over the x-axis. Remember, the x-axis is this one, the horizontal one. The y is this one, the vertical one. So if I reflect that over x, I'm going to keep the x value the same and just switch the opposite y value. That's going to be negative 5, negative 1. That's the reflection over the x-axis. If I reflect over the y, remember I'm going to change the x-axis to its opposite and keep the y. So I'm going to have now 5, positive 1, because it's going to go whoop over here. That's going to be like on top of this other thing that I already drew, but there it is, 5 and positive 1. That's the reflection over the y-axis. And then part C says reflect it over the x followed by the y. All right, well now we have to kind of scoot it this way, over the x first, then over the y. So to do that, we already have reflected over x. I'm going to take this now and reflect it over y. So I'll keep the keep the y the same and just change the x to its opposite. So instead of negative 5, negative 1, it's going to be 5, negative 1. That's going to be like right over here. There's 5, negative 1. That's the reflection, again, over x, over y, and over x and y. My marker is kind of running out of juice now. Let's take a look at some other ones here. Let me see if I can move this screen. I can't. I figured out how to move my screen, so I'm feeling good. Number 14 and 15 both say to graph the inequality on a number line. Well, in order to do that, we need to have a number line. So let's see. Here's our number line. We'll do maybe number 14. This marker looks like it's going to work better, but it could be deceiving me. It says graph this inequality. So what I'm going to do is I see that x is going to be greater than or equal to 5. Well, I'm going to go ahead and put the numbers 4, 5, and 6 on my number line. I see that it is a greater than or equal to, which means it could include 5. I'm going to have a closed circle on 5. Remember, closed circle when it's or equals to. And then I look at that, it says x is going to be greater than or equal to 5. And if I look at the tip of this arrow, it's going to look like a greater than sign. So my arrow points to the right. There you go. If you look at number 15, same kind of deal. We'll have our number line. We see that m is going to be less than or equal to negative 2. So I'm going to put negative 2 on here. A number that's bigger than that, negative 1, and a number that's smaller than that, negative 3. It's less than or equal to, so I'm going to have a filled in circle on negative 2. And because it's going to the left, right, that tip of the arrow looks like a less than sign. And there it goes. Just a reminder for you, that works every time that we have our variable on the left side. So we always love to have our variable on the left. Hey, let's get into numbers 16, 17, 18, and 19, where we can actually solve the inequality. And we solve the inequalities by using the inverse operation. So just to do a little sampling of these, let's take a look at numbers 18 and 19. All right, so we'll start off with number 18. And again, if you have questions on 16 or 17, obviously, you can let me know. And we'll look at those a little bit more in depth. All right, so for this one, we have a b that's attached to 4/3. 4/3 times b is less than or equal to 12. I want b alone, so I use my inverse operation to get rid of that 4/3. Since it's being multiplied, I'm going to divide it. And I'm going to do that on both sides. So now I have 4/3 divided by 4/3. That leaves me with just b, which is what I wanted the whole time. I'm going to keep that sign the same because I haven't switched the b to the other side or anything like that. And then here, 12 divided by 4/3, I'm going to break that off to the sides here. 12 divided by 4/3. I can think to myself, keep, change, flip. Kind of running short on paper here, but I'm going to keep the 12, change the sign to division, and then flip this to 3/4. Just for fun, I'll put the 1 under the 12. Now I have two fractions, and I can multiply straight across or cross simplify. I see 12 and 4, and they have a common factor of 4. 4 goes into 4 one time, and 4 goes into 12 three times. Now it's 3 times 3 on the top, 1 times 1 on the bottom. That's going to be 9 over 1, or just 9. So B is less than or equal to 9. It does say to solve it and graph it. So let me graph this really quickly, which is basically just what we did, just like what we did on the last problems. Here we go. It's less than or equal to, so I have a closed circle on 9. And since my B is on the left side, this is going to be the tip of the arrow. It looks like a less than sign, and there's my arrow pointing left. Let's take a look at number 19. 19 is very similar. We're going to solve this in a similar way, but there's a little twist on it. So check it out. My P is attached to the 12. I want P alone, so I'm going to divide by 12. That seems so easy, right? 12 divided by 12 is 1. I have just the P alone over here. On the other side, I have 17. If I can talk. I have 72 divided by 12. As I choke. All right. 72 divided by 12 is 6. I have 6 is less than P, but remember, we love to have our variable on the other side. So I'm just going to switch these around, put my P over P over here. Keep the sign switched so that it's always going to be chomping towards the P. So now I have P is greater than 6. To graph this out, put my 6 in the middle, a number that's bigger than 6, a number that's smaller than 6. There we go. We have 5, 6, and 7. I'm going to have an open circle on 6, and that arrow is pointing to the right. Because P is greater than 6, that's going to include numbers that are bigger than 6, like 7. That's number 19. Let's get into some of these word problems. I know these can be a little bit tricky to read through them all carefully. So first up, number 20. A hurricane has wind speeds that are greater than or equal to 74 miles per hour. Write an inequality that represents the possible wind speeds during a hurricane. Well, let's see. We know that the wind speeds, which I'm going to just call W, because I don't know. W sounds good for me for wind. And it's going to be greater than or equal to 74 miles per hour. So let's make a greater than or equal to sign and put 74. The wind speed is greater than or equal to 74 miles an hour. That's number 20. Number 21, it says two vertices of a triangle are F, that's 1, -4, and G, 6, -4. Find two possible points that represent the third vertex. So for this one, again, they're going to give you the coordinate plane, making this a lot easier for you. I'm going to go ahead and draw it out here, and you can see I didn't even draw a straight line. Shame, shame, shame on me. But I'll do the best here to graph these points. Very quickly for you. So we have point F, that's 1, -4. So I'm going to go over 1 and down 4. Boop. There's point F. I have G, which is 6, -4. So, oops, I need to add on some things here. There we go. There's 6. Here's -4. That's G. So I know that these are 2 points of a triangle. There's got to be a third point, right? And so we want that triangle to have an area of 20 square units. So think about this for a moment. This is 1, -4. This is 6, -4. So the distance from point F to point G is going to be the difference between my x values. So 6 and 1. I could count this up as well, but I'll find out that this is 5. If the length here is 5, and I want to think about my area formula, area for a triangle is 1/2 times base times height. I'm trying to find an area here of 20 square units. All right, so thinking this through, I know that 5 times 4 equals 20. But it's not 5 times 4, remember, it's 1/2 times 5 times the height. So I would need to make that height 2. 1/2 times 5 times 2. 5 times 2. Oops. Did I just mess up that whole thing, I think, in my head here? Hold on a minute. Let me look at this again. We don't want it to be 4. We want it to be double that. Right? We want it to be 8. 5 times 8 is 40 because half of 40 is 20. So we need our height here. Whatever our points are going to be, we need the height of that triangle to be 8. So thinking about my height, I can have a point that's going to be 8 higher than this. If I count this up, 1, 2, 3, 4, 5, 6, 7, 8, I could have a point that's located right here. That could be point 1, 4. That's 8 away from this. And if I were to trace that in, you could see what that triangle would look like. That would be a triangle that would have an area of 20 square units. Or I could have a height that maybe my point is over here, right where my A was. Right? Now I can kind of trace that triangle, and you can see that would have a height of 8. I could even have a point that's here, or here, or here, or here. That's why it says select 2 points that are possible. Any of those points, the x value can change. The y value has to be 4. I guess we could even flip this around. I guess I could zoom out a little bit. We could flip this around and think that our triangle is going to go down here, in which case I would take this -4 and add 8 to that. If I did that, my answer would be a -12. So I could have points that are at -12 as well. But regardless, I've got to make sure that these extra points are going to be 8 spaces away from these spaces here. Whether I go up to +4 or down to -12. That's number 21. Kind of a tricky one to do on paper. If questions like that appear on our test, it'll be a little easier because you're going to have the grid that's going to be given to you. Let's take a look at number 22. Number 22 says the table shows the melting points in degrees Celsius of several elements. Compare the melting point of mercury to the melting point of each of the other elements. All right, so here's what we're going to do. We're going to compare mercury to everything else. I'm going to use M to represent mercury, R to represent radon, B to represent bromine. You get the idea. C is cesium and F is francium. So I'm going to say that mercury is actually greater than radon because it's a bigger number. -38 and 83/100 is bigger than -71. For bromine, I'm going to say mercury is less than bromine because mercury is a smaller number than bromine would be. The same thing is true for cesium, smaller, and the same thing is true for francium. There you go. So when we're talking about making a table, this is my table right here. It's kind of showing the relationships between all those different elements. Let me see if I can scooch up my page a little bit. I guess that's as far as we can go. So number 23, our last question on here. Let's take a look at it. It says, a map shows the vertices of a campsite area are 25, 10, 25, -5, -5, -5, and -5, 10. The vertices of your tent are 0, -3, 0, 6, 10, 6, and 10, 3. Or 10, -3, sorry. The coordinates are measured in feet. What % of the campsite is not covered by your tent? Oh my goodness. Okay, so we've got to graph this out. So once again, if this were a question, you would be given a graph to work with, making this a little bit easier. I'm going to go ahead and count by fives, I think. 5, 10, 15, 20, 5, 10, 15, 20, 5, 10, 15, 20, 5, 10, 15, 20. So I'm going to start off with the campsite area here. So we have 25, 10, 5, 10, 15, 20. I guess I need to go to 25. There's 25, 10, which is like here. I'll label that point. We have 25, -5, 25, -5, which is here. We have -5, -5. That's here and here. And we have -5, 10, which is here. Now I'm going to go ahead and connect these points here to represent our campsite space. This is kind of a weird way to think of it, but this is basically the size of your campsite. Just to help myself out as well, I'm going to look at these x values. I have -5 all the way up to 25. This is 25 from here to 0, and this is 5 from here to -5. That means the entire base here is 30 units. which I think it goes on to tell me that these are measured in feet, so 30 feet long. And then my y values, I have 10 up here, so the distance from here to 0 is 10, and -5 here, the distance from here to -5 is 5. That means this is 15 feet. So I basically have a rectangle, 30 by 15. Let me plot where my tent is here. The tent is at 0, -3. So that's 0, -3, which is like right about here. 0, -3. We have 0, 6. So 0, 6. Oops, that's going to be like right about here. Again, my hand-drawn chart here is not the best. I have 10, 6, so I'll go over 10 and up 6. And I have 10, -3. It's like right about here. So as I look at this, I can kind of show where my tent is. The tent, in all, is going to be 10 feet going one way, and going up and down, looking at my y values, I have 6 plus 6 plus 3, really, absolute value, is going to be 9. So I have a 10 by 9 tent. The tent is going to be 90 square feet, because 10 times 9 is 90. The camp space is 30 times 15. Gotta think about this one. 30 times 15 is 450. So 450 square feet for the campsite. And the question is asking me, what percent is not covered by your tent? Right? So I want to figure out what my percentage would be here. So I have 90 square feet is the tent. 450 is the total. So 90 out of 450. Now here's where a calculator might come in handy. And I just had my calculator. I think I took it with me to testing today. All right, let me pull up my calculator here. All right, so 90 divided by 450. Oh, I could have done this one, I think, in my head. We end up with 2/10, right? Which is really 20%. What that means is the 90 out of the 450, in other words, the amount of space needed for your tent out of the whole site is 20%. Now the question says, what percent is not covered by your tent? So I have to think 100% minus 20% equals 80%. 80% of this whole thing is not covered by the tent. And that kind of makes sense. Like if I shade in all the parts that don't include the tent, that's a pretty large amount. So 80% is our answer for number 23. Guys, that is the practice test from page 406. I hope this has been helpful for you as you're reviewing this a little bit on your own. If you have questions, always feel free to email me, or you can ask me during our class. Thank you very much for watching. I hope it's been helpful.